Okay, we're in section 36 of the notes. This is the 2x2 linear systems, 2 lines, 2 unknowns. We're basically looking for the point of intersection. So the technique we're doing here is what's called addition or elimination. We covered the material. Hopefully you understood what's being presented to you. We certainly did some examples. And the examples that we did were done in class at the whiteboard or at the blackboard. So we did, example 1, example 2. And again, we did it by addition elimination technique. And we also did a word problem. Now we're at the stage where hopefully you study that material and you have a good understanding of what we presented to you and you're capable of doing problems on your own. So what I'm going to do is I'm going to go to the whiteboard. I'm going to switch over. Excuse me. I can get my whiteboard open here. Let's see what we got here. And I'll get the whiteboard opened. Nope, that's the wrong thing. Let's see, whiteboard. Just give me a second here. Do a new share. Okay, you should see the whiteboard now. And again, we're in section 36 of the notes, and we're doing the homework. Again, the hope is that you've done the homework already and you feel comfortable about it. Maybe watching this just to reaffirm what you've done is correct. Let's look at number 1. Again, we're doing addition or elimination. And x minus y equals 2. That's an equation of a line. And we have x plus y equals 8. That's also an equation of a line. One thing I want to claim to you is we're going to do the addition method that things do line up. Most importantly, the equal signs line up. But it's nice to have everything lining up. For example, the x's are lining up, the y's are lining up, and the numbers are lining up. But the only real requirement is that the equal signs line up for us to add these equations together. So I can put a little line over here. Let's remind you're going to add this together. So x plus x is 2x. And, plus y minus y, there's no y's. And then when we get a plus 2 is 10. Divide both sides by 2, get x equals 5. What I would do now is take this, plug it in anywhere you like. I'm going to plug into the second equation. What would that give you? If x is 5, what would y have to be? Y would have to be 3. This is an ordered pair of numbers, x comma y, 5, comma 3. I want to check it. I'm going to check it in the original system. First equation, 5 minus 3, equals 2. That's correct. Second equation, 5 plus 3 equals 8. That's correct. Also look in the answer key. Make sure you're staring at that. And of course, you are staring at that. Let's go to number 2. And number 2 is a system of linear equations. There's 2 equations, 2 unknowns. 3 minus 2x equals 4 minus 3y. 3x plus 2y is equal to 5. Well, again, I want to point out if we're going to add these together, the equal signs line up so I can add them together. The problem, though, is this. Things aren't lining up over here. So I want to get them in standard form. That's x, y equals a number. Let's do that. It's an extra step, certainly. Minus 2x plus 3y is equal to 1. I want to tell you what I did over here. I added 3y to both sides. And of course, I have minus 3x plus 3y then, and subtracted 3 from both sides. Now, what do you get in the second equation? You get 3x plus 2y is equal to 5. Unfortunately, if you add these together, nothing disappears, right? For example, you add the x together, you would get 3 minus 2, which is 1x. That didn't disappear. If you add the y's together, 3 plus 2 would give you 5. That didn't disappear. So we need to select someone to get rid of. And for sake of argument, what I'm going to get rid of is I'm going to get rid of the x's by looking for what's called an LCM between 2 and 3. What's the LCM between 2 and 3 is 6. So I'm going to try to make them both 6s, but I want one to be a 6, the other one to be a minus 6. So through the addition, they would eliminate. Let's put this down. I'll multiply the top equation by 3 and the second equation by 2. Now, what would you get there? Let's write this down. Minus 6x plus 9y is equal to 3. I'm multiplying both sides of the equation by 3. Second equation, 6x plus 4y is equal to 10. If you add these two equations together, you're going to get 13y. The x's disappear. That's why they call it elimination, equals 13. Now, of course, this is pretty simple. Y would be equal to 1. What I would do is take this, plug it into any equation you like. I'm going to plug it in here and see what I get. You get 3x plus 2 equals 5, 3x equals 3, or x equals 1. So I'm going to write the ordered pair down. X is 1 and y is 1. I want to check it in the original. Let's write this down. Pretty easy because both x and y are 1. Not much to memorize there. 3 minus 2 equals 4 minus 3. Well, 3 minus 2 is 1 and 4 minus 3 is 1, so that works. What's the next thing going to be? 3 plus 2 is equal to 5. It also works. Also look in the answer key to make sure you're staring at that very same answer. Let's go to number 3. And again, we're trying to master the technique. And you have two equations. First equation, it's a linear equation, 2x minus 2y is equal to minus 2. The second equation is minus 3x plus 6y is equal to 6. Well, again, the most important thing is the equal signs line up, which they do, and everything else is lining up, which is nice. Now all I got to do is select something to get rid of. I'm going to say I want to get rid of the x's because it appears to be pretty easy to do that. How would I do that? Well, LCM between 1 and 3 is 3. So I want to make 1 a 3, the other one to be minus 3. So I'm just going to multiply the top equation by 3. And what do you get? You get something pretty simple. You get 3x minus 6y equals minus 6. Second equation is minus 3x plus 6y equals 6. A bar, add them together, you would get 0 equals 0. One thing I noticed, when someone says 0 equals 0, I would say they're speaking the truth. So time for me to think. What does that mean then? It means that both of these equations up here are the same equations. They're the same. In other words, if you graph them out, they both would lie on top of one of themselves, all right? So we call this, and again, I'll read this to you from the narrative in the problem, but we call this to be a dependent system. That is, they're on top of one another. So what I'm going to do over here is read it to you. It says over here, if the equations are independent, give the answer as a point. I can't give the answer as a point because these things lie on top of themselves. That means they have all points in common. So there's no one point they have in common. They have all points in common. Next up, it says if the equations are dependent. Dependent means they're the same line. These are the same lines. You can verify that by graphing them out. But here's what they say. If they're dependent, enter x for the value of x. And WebAssign will do this too. And then it says for y, it says solve for y. And you want y in terms of x. So take any equation you like, any one. I'm going to pick this one here. And I'm going to try to solve that for y. So you get minus 3x plus 6y is equal to 6. 6y is equal to 3x. I'm adding 3x to both sides, plus 6. Divide both sides by 6. You get y. 3 divided by 6 is 1/2 of an x. And 6 divided by 6 is 1. So I'm going to say what y is. This is what y is. Y is 1 plus x over 2. If you like, you can check that. I say probably the best place to check at this point. Trust me, look at the answer key. And what does it say? X comma 1 plus x over 2. All right, let's go to number 4. I know this seems tricky to you. Put number 4 down for you. And what does 4 say? Solve by the addition method. And what do I say? I'll write this down for you. I'm seeing fractions and hope that's not too alarming to you. If it is, though, get rid of the fractions. Okay, so let me just point this out again. It's critically important equal signs line up, and they do. So you could add these things together. Unfortunately, adding together, nothing disappears. So what I'm going to do is I'm going to select someone to get rid of, and who I'm going to select, in this case, I'm going to select the y's. So what's the least common multiple, for both in terms of fifths, by the way, between 2 and 3? I would say 6. So I'm going to multiply the top equation, write this down for you, by 3, we'll go through the work, and the bottom equation by 2. Again, we'll go through the work. Let's do that now. 3 times 1/3, I'll actually do the work. It's 3/3 of an x. 3 times minus 2/5 is minus 6/5 of a y. And 3 times minus 1 is minus 3. Not so bad. Let's do the second one. 4/3 x plus 6/5 y is equal to 10. Put a line down, add them together, and what do you get? 7/3 x. The y's disappear, and you get 7 over here. Now someone says, what's x over there? It looks pretty simple to do. X would have to be 3. I'll write that down for you. All right. So I'm going to say, I know what the x is, and I want to get the y now. I'm going to do a little differently than the past. And what I want to do is I'm going to just erase something for you. Erase this over here. Erase this over here. And this time, I'm going to get rid of the x's now. Let me put that down for you. Get rid of this over here. So what I have to multiply the top by? Minus 2 now. Push this on the side. And I'm going to go for it. So what you got over here? Let's see, minus 2/3 x plus 4/5 of a y is equal to 2. 2/3 of an x plus 3/5 of a y is equal to 5. Add them together. Well, the x's disappear. What do you get? 7/5 y equals 7. Well, that looks pretty easy to do as well. Y would equal 5. So I'm going to write down what I believe the answer is. X is 3, y is 5. Put a box in that. Again, if you want to, you can check it. You check it by plugging it into your original system. I'm just going to look at the answer key where they say 3, 5. Feel uncomfortable about that. Go to number 5. Again, I realize for some students, particularly students who are not studying or doing homework, this appears to be going quickly. You have to study, you have to do homework to see this is not quick. All right, let's do number 5. Number 5, I'm reading it. It appears to be a mixture problem. And not that I'm going to say that all mixture problems are this simple, but typically we're going to mix two things together to get a mixture in the end. I'm going to read it to you, and I'll read you what it says. Formula says 2 powder vitamin supplements that are powders. The first powder is 25% B1. I'm just going to summarize this by writing it down. And it's 5% B2. That doesn't look right. I'm just going to erase that a little tiny bit. Okay, the next one is 25% B1. Again, I'm just reading. And it is 15% B2. It goes on to say how many milligrams of each should be used. I don't know. So I'm going to say X milligrams and Y milligrams. Now, why am I using 2 letters? Well, because in this section, we're using 2 letters. All right, I think it's going to help me if I can do that. How many milligrams of each powder should the pharmacist use to make a mixture that contains 165 milligrams of B1 and 43 milligrams of B2? All right, let's write this down. So I'm looking at my picture. I'm going to say 25% of X milligrams is B1, and 25% of Y, these are in milligrams, is going to be B1. So B1 plus B1, well, is going to equal the final, which is 165 milligrams of B1. What's the next line going to be? 0.05x, that's how much B2 in milligrams is from that first box, plus, let's see, 15% of Y, that would be B2. How much B2 I have in the end? 43 milligrams. So what I'm going to do is select someone to get rid of, and for the sake of argument, I want to get rid of the x's. So what I'm going to do is multiply the second equation by minus 5. Let's go for that. I'll write that down for you. 0.25x plus 0.25y equals 165. Let's see, minus 0.25x minus 0.75y equals minus 215. These problems are typical that they're written in a very nice way, that they're going to work out beautifully. So what do you get here? You get minus 0.5y equals, let's take a look at that. It's going to be a negative number, 35, 40, 50. Well, it doesn't look too bad. I'm going to say y would have to be 100. Right. Now, how do I get the x? I'm going to say take this, plug it into one of those equations. Now, which one? That's up to you. I'm going to plug it into this one here, though. And what are you going to get? 0.05x plus, well, 100 times 0.15 would just be 15, right? Equals 43. 0.05x. I'm going to take 15 from both sides. And what do they give you? I guess that would give you 28, right? Make sure I did that right. 38. Yeah, it looks pretty good. And now I'm going to divide both sides by 0.05. All right, so I'll put this down for you. So x would equal 28 over 0.05. All right, I know this looks difficult, but I think we can do it. I'll push this up a little tiny bit for you. All right. So, when I'm doing this, you might do a reticle a bit differently than that, but it really doesn't look that bad. And what I'm going to do is multiply top and bottom by 100. And what would it give me? It would give me 5, and I get 2800. I'm just going to go through the division with you. It's really easy division, but let's see if we can do it. So I'm going to say 5. That would be 25. This would be 40. And that would be 8. So what is it? 580. So x is 580. So I have no idea what those numbers mean. This is why we emphasize that you probably should have, work done. You can read this. Now, what do I know? Well, I know this is 580 now. Milligrams of this. How much of what? The other guy, y, was 100 milligrams. So read the answer. What does it say? 580 milligrams of the first powder. I have that written down. 100 milligrams of the second powder. All right. I'm going to call this quits because we're done with the homework. And what I want to do is just briefly go back and talk about the SAGE code now. Okay, so we just finished problem number 5 in the notes, in section 36. Now we're going to do SAGE. Again, that red link over there is clickable. It's going to bring us to sagemath.org. If your computers are properly configured, it will open up a web browser and bring you directly to the sagemath.org website. The way we've been dealing with this, we basically just go to CoCalc, which is the online version of SAGE. You don't have to install any software. And, we've been doing this for some time now. What we're going to be doing is just, I guess, going through the code as we've always done in the past, right? So I'm going to try to open up a SAGE instance, a sort of project, and SAGE project, by the way. Give it a second. Takes time to load. A new file. And I'm going to do a Sage worksheet. And that's all we've been doing all semester, Sage worksheet. What are we trying to get you guys involved in? Coding. Remember, shift return. That's done. I'll do my var x comma y. We're defining a variable x and a variable y. And why is that? I guess that's what we're doing in the notes. Now, somebody say, could I copy paste this? Give it a try, see if it works. Let's take this. And I'm going to type that in. No, I'm just going to copy paste, right? I'm going to type that in, shift return. Now, I want to tell you what this is doing. It's taking two equations with two unknowns and solving it. Now, someone says, I wonder if I could do that on problems that were difficult. Well, let's try. I'm going to scroll back in the notes. And I want to see if I can do this one over here. So I'm going to see if I can type it in. I'm using this as a template. So it's x divided by 3 minus 2 star x. I'm sorry, it's 2 star y, right? Divide by 5 equals minus 1. What's the second equation? 2 star x, okay, divide by 3, plus 3 star y, divide by 5, is equal to 5. And I want to solve for x and y. I'm just using the same code over and over again. So I'm going to point out, if you look at the answer key, it says it should be 3, 5. What do they have? 3, 5. All right, pretty simple stuff. Thank you.